All right, let's continue on here with numbers 2 and 4. If you need to see 1 and 3, you can take a look at the previous video. So for number 2 here, I'm going to count the degrees. So that's going to be a 1 there and a 1 there. I don't count the one in front because there's no x there. So this will be degree 2 and negative. All right, so we add those exponents up. So degree 2 negative, if you look back at that chart, it would be down to the left, down to the right. We have zeros at positive 3 because of the x minus 3 and negative 1 because of the x plus 1. Both of those have an exponent of 1, which means they're going to cut. So I'll draw those here and here, respectively. And so this will be our basic parabola, not too surprising there. All right, next up here we got number 4. So this one here, I see I have the x out front, so I need to count that. It doesn't have an exponent, so it's going to be a 1. So 1 plus 4 plus 3 is going to be a degree of 8. I see we have a negative out front, so that's going to be down to the left and down to the right. I have zeros here at 0. Anytime you have the x GCF'd out front, no matter what the coefficient is, it's going to be 0. And then that is multiplicity 1, which is a cut. And then at negative 2, we have a multiplicity of 4, because the exponent is a 4, which is going to be a bounce. And then at negative 1, we're going to have a multiplicity of 3, which is going to be a cut. So the multiplicity is coming from the exponent. And then if it's odd multiplicity, it's going to cut. Even multiplicity is going to bounce. Okay, so let's draw those all here. Oops, that's negative 3. That's the wrong spot. Okay, so negative 2, negative 1, and 0. Okay, and then negative 2, the first one is going to be our bounce. And so since I'm coming from the bottom, that means I bounce back down below. So just think about it, top half versus bottom half. And so since I came from the bottom half, I'm going to bounce back down. And I'm going to cut through the x-axis. Now I'm switching to the top half there. I'm going to cut back down to the bottom half. So you can see that I kind of switch from top to bottom or bottom to top every time except at negative 2. That one I stayed underneath. So we saw 2 examples of bounce here. So we have the bounce over here on number 3. If you come from the top, you're going to bounce back up to the top. And then on number 4, if you come from the bottom, you're going to bounce back down to the bottom. It's the cuts that you switch from top to bottom or vice versa. All right, next up here, we're going to do some nonlinear inequalities. And so you can see that all 4 of these questions are matching up with the question up here on number 3. So we're just going to use this graph to help us out with this. So the first one here is asking us, when is this less than 0? And so what I'm going to say here is that this is below the x-axis. And so where is this below the x-axis? I really only see one little section, which is right here. And so that is going to be from 0 to 1. And we're talking about our x values there. So at the x value of 0, it's underneath, it starts being underneath the x-axis, and then at the x value of 1, it finishes. I'm going to use parentheses there because at 0 and 1, it's technically not below the x-axis. It's at the x-axis, okay? All right, so the next up here is the next question is asking us, okay, well, when is that greater than 0? So when is it above the x-axis? And so for that one, I would say this section here, and this section here, and this section here. And so that's going to be from negative infinity to negative 3, from negative 3 to 0, and then from 1 to infinity. So you can see I did have to skip over that negative 3 because at negative 3 it's technically not above the x-axis, it's at the x-axis. And so I had to skip over that. So just all those sections that are above it, and we're describing that with the x values. Okay, so then next up here, we're going to continue on, and this time, and let me get a new color here, do pink. So this one is less than or equal to 0. So this means at or below the x-axis. And so I see that this is still below the x-axis, but I also need to include this point that's at the x-axis. So for this one, I'm actually going to say bracket negative 3 all by itself, and then bracket 0 to 1. So we are using brackets now because it can be at the x-axis, so the x-intercept should be included. And then I also need to include that negative 3 there because technically it is at the x-axis. So then our last one over here would be, I would say that this one means at or above the x-axis. So on this one, I would actually say this whole section all together I can put, because through from negative infinity to 0, it's never below the x-axis. It is always at or above. At that one spot at -3, it is at the x-axis, but there's no break there now. Okay, and then I'm going to say that it's also at or above the x-axis over here, and so that's going to be from 1 to infinity. So you can see these two are actually kind of related, except that we kind of, if we have ones that we take a gap here, we kind of combine those here and we use a bracket. These are also kind of related, except that we had to include this extra one with a -3. All right, we'll do some more graphing here. So on this one, we'll add up our degrees. So it's 4 plus 3 plus 2. So let's see, that is going to be a degree 9 if we add all those up, and it's positive. So degree 9 positive, according to our chart, is down to the left and up to the right. Our zeros, we have an x out front, so that's going to be at 0. The exponent is 4, and so that's going to bounce. We have one at -4 with a multiplicity of 3 because of the exponent, so that's going to cut. And then at +1 with a multiplicity of 2 because of the exponent, so that's going to bounce. So what do we got? We got -4, we got 0, and we got 1. Okay. So -4 is the one that's a cut. And then we have 2 bounces. So as I come from the bottom, I'm going to cut through the x-axis, and now I'm on the top. But the rest of the way, I'm just going to bounce, which means I'm just going to stay up here on the top half. We would only go through it if it was a cut. And since those two are bounces, they're going to stay on that top half. All right, next up here, we have degree 6 plus 3 is 9, plus 2 is 11, and that's a negative. We got an x out front, so that's 0 with multiplicity of 6, which will bounce. 2 with multiplicity 3, which will cut. And then -1 with multiplicity 2, which will bounce. Once again, if the multiplicity is odd versus even, that's what tells us the cuts or the bounce. Oh, my degree odd negative is going to start up here and then down there, according to my chart. All right, now I'll draw my x-intercepts, so 0, -1, and 2. So -1 is a bounce. And then 0 is another bounce, and then this one will be a cut. So I'm going to hit this one, and then bounce back up, and then bounce back up again, and then finally I'll cut down through the bottom. All right, so sometimes here these don't come in factored form, and so if that's the case, we need to factor. Now I can actually already tell that this is degree 3 negative. Since this is now in standard form to start, we can already tell the degree just by looking at the biggest exponent. We do not add up the exponents when there's no parentheses. We just look at the biggest one. So I already know the end behavior is going to look like this. So, but now I'm going to factor it. I see my leading coefficient is negative, and I have a GCF of x. Whenever that happens, I like to take out a negative x. I think that makes the rest of the factoring a lot easier. If I do take out a negative x, it switches the sign of everything inside, so that'll become positive 2x squared plus x minus 3. I'm now going to do a diamond or x factoring here with -6 on top, since that's a times c. And then b on bottom is 1. So that would be a +3 and a -2. Remember, in this case, I need to use my grouping technique, so I'm going to split this up as 3x minus 2x from that x. I have 2x squared here plus 2x squared plus 3x minus 2x minus 3. And then we'll do the grouping here. And the first group I can take out an x, which leaves me with 2x plus 3. Second group, I have to take out a -1. It looks like I can't take out anything, but I'm going to take out a -1, so I get that 2x plus 3 matching up. So now I have x minus 1 times 2x plus 3, and then I still need this -x. I've kind of been ignoring that, but I'm going to add it out front, okay? Awesome. So my zeros here, well, I have one at 0 with multiplicity 1, so it's a cut. At 1 with multiplicity 1, which is also a cut. And then 2x plus 3, that one, if you want to set it equal to 0, I'm going to say 2x equals -3, and then divide by 2, so x equals -3 over 2. That's multiplicity of 1, which is a cut, okay? All right, so I know where 0 and 1 are. If you're not sure about -3 over 2, I would just think that -4 over 2 is -2, and then -2 over 2 is -1. And so this is obviously right in between -1 and -2, so it's -1.5. All right, all of these are cut, so I'm going to cut down to the bottom half, I'm going to cut back up to the top half, and then I'm going to cut back down to the bottom half, and there we go. You'll notice here that if I add up the exponents in the factored form, 1 plus 1 plus 1, it actually gives me that third degree that I had in the standard form. All right, next up, number 8 here. So for this one, I already see it's degree 4 and positive. And so I know it's up to the left and up to the right. I see when I factor this, I can GCF x squared, which gives me x to the second minus 2x minus 3. Do some more factoring here. Negative 3 and negative 2 would be negative 3 and 1 for my a times c up top and my b on bottom. I actually don't need to use the grouping technique here. You can use it if you want. It'll still work. But whenever I don't have an a value or the a value is 1, I can just use these numbers here. It's going to be x minus 3 and x plus 1. All right, so I confirm that it's still fourth degree in the factored form. And so I have zeros at 0, multiplicity of 2, which is going to bounce. At 3, which is multiplicity 1, which is going to cut, since it's first power. Negative 1 is also multiplicity 1. Okay. So I only have one bouncer here, and that is at 0. And so I'm going to cut through at negative 1. I'm going to bounce off 0, and I'm going to cut through at 3. All right, for these ones down here, we're taking a look. These are all, you can see, matching up with number 7 up here that we already did. And so it's just those same questions as before. So then the first one is, where is it below? And so I'm going to say it's below right here and then also over here. So that would be from negative 3 over 2 to 0. And then from 1 to infinity. Next up is, where is it above? Greater than 0 is above. So it's over here and in here. So that's negative infinity to negative 3 over 2, and then from 0 to 1. Next up, where is it at or below? So in this case, I actually think that's going to be the same as the previous, except there's brackets. I can't combine any ones. And I did get all my x-intercepts. You got to make sure when it's the at or below, you get all your x-intercepts. And I did here with my brackets. So there you go. And then lastly, at or above. So that's greater than or equal to 0, so that's over here and here. Once again, this one, I don't need to combine anything. I included all my x-intercepts, so this is going to be the same except with brackets. All right, next up here we have a third degree. I can see is the biggest exponent. It is in standard form again. And so I know that it's going to go down to the left and up to the right since it's positive. We'll do factor by grouping here. So the first group I can take out x squared. The second group I can take out negative 4. And that'll give me x squared minus 4 times x plus 3. But I can actually break down that x squared minus 4, x plus 2, x minus 2, and then x plus 3. So I get a negative 2, a positive 2, and a negative 3. All of them are multiplicity 1 because I don't really have any exponents there. And so I'm going to cut through to the top half, cut back down to the bottom half, and then cut through to the top half. All right, next up over here, same idea. Degree 4 positive means up to the left, up to the right. I'm going to group them together. The first group I can take out x to the third, which leaves me with x minus 2. And then the second group I can take out a positive 8, which leaves me with x minus 2 as well. So I get x to the third plus 8 times x minus 2. I can actually keep factoring this one as well. We have our perfect cubes here. So that's the binomial and the trinomial. I'm going to leave this x minus 2 alone. So the binomial, remember, is x plus 2. And then we have, from that x plus 2, first thing times itself is x squared. First thing times second thing is 2x. And then last thing times itself is 4. And I already did the plus here, but it's same. And then since this one was a plus, that's plus. And then we have opposite, and then always positive. Now, I think we can all see that we have zeros at negative 2 and positive 2 from those parentheses, which are going to cut. And this one, however, I will tell you that after SOAP, it's always imaginary. And for this one, we're not going to graph the imaginary zeros. So after you do SOAP, that trinomial is always imaginary zeros which are not graphed. So I'm just going to graph the two that are there. And so this is just going to look something like that. All right, next up, numbers 11 and 12. So right away I can see that this is degree 4 positive, so we know we're up and up. And we need to factor this one, so I do need to do a times c up top. Actually, 4 times 225, do I know what that is? Oh, it's 900. Okay, so that's a times c, and then b would be negative 109. And so this is actually not as hard as it looks. It's negative 100 and negative 9. I do need to do my grouping technique here, so I'm going to split this up, and I'm going to say 4x to the 4th minus 100x squared minus 9x squared plus 225. The first group I can take out a 4x squared, which leaves me with x squared minus 25. The second group I can take out a negative 9, which will leave me with x squared minus 25 as well. So I can group this together now, 4x squared minus 9 times x squared minus 25. But I can actually break that down even more. So we have the difference of perfect squares, 2x plus 3, 2x minus 3, x plus 5, x minus 5. Okay, so we have ones at negative 3 over 2 here. If you set 2x plus 3 equal to 0. Get 2x equals negative 3, and then divide that by 2. We also have a positive 3 over 2. We have a negative 5, and we need another line for our positive 5. So all of these are multiplicity 1. These are all going to cut. All right, so we have negative 5. Negative 3 over 2 would be negative 1.5. We saw that earlier. And so this one will be negative 5, cut back up, cut back down, and then cut back up. All right, and then lastly here, number 12. So this is degree 4 negative, and so that's going to be going down and down. Now for factoring here, I never like factoring with a negative a value. So whenever that happens to me, I always take a negative 1 out front, and then I just look at it as I switch all the signs inside. As long as I keep that negative 1 out front here, I am allowed to do that. And so I'm going to go ahead and factor this like this. So we're going to do 9 on top for my a times c and negative 10 on bottom. So that'll just be negative 9 and negative 1. I don't really need the grouping here. I just need to know that since this is 4th power, it's going to be x squared minus 9 times x squared minus 1. If you FOIL that back together, you can see the x squared times x squared gives me x to the 4th. If you did the grouping technique on that one, it would show you it better. But I'm just going to do it like this. So x plus 3, x minus 3, and then x plus 1, x minus 1. So difference of perfect squares there. So we have negative 3, positive 3, negative 1, positive 1. All of them multiplicity 1. Means they're all going to cut. I'm not doing anything for that negative 1 out front. It's not a 0, but it did determine that it was a negative leading coefficient instead of a positive, okay? Okay. So now we have negative 3, negative 1, positive 3. They're all cuts. We're going to cut through, cut through, cut through, cut through.